Hello everyone and welcome to my teaching channel. This is for Danny World of Maths, and this is basically going to be me teaching every subject in mathematics for high school, just working with everything. And starting out with Algebra 1, we're going to talk about variables and expressions. And we all owe it to one man, Mr. Muhammad ibn al-Khwarizmi. And he is an interesting name right here. He's an absolutely amazing mathematician who basically came from modern-day Iraq in about the 9th century, and he was both a mathematician and astronomer, like most mathematicians. They pulled double jobs back in the day. And he loved to solve puzzles, and he used words instead of what we use today as notations for mathematics. In other words, instead of using variables and letters and numbers, he actually used words to express equations and expressions and stuff. So let's just look at how he actually did it way back in the day. But before we can get into that, we do need to talk about the vocab of this idea about variables and expressions, because one of the major things that a lot of students struggle with is the vocab ideas that we go over in each section, okay? All right, so first and foremost, we've got quantity, and quantity is a count of something. So in other words, if I talk about a quantity of 5, I'm talking about 5 of something. So like for my sons, I talk about we got 15 apples. The quantity would be 15. It just counts as the numerical amount of something. Now, instead, if I tell them I have a bag full of apples, and I don't say specifically how much there are, I'm just talking about a variable amount. It could be 15, it could be 20, it could be 300, who knows? But it's just a variable amount. It's kind of a placeholder. So like when I hold the bag in front of them and say, okay, here's a bag of apples, I'm just talking about a nondescript amount. Okay. Now, when I'm talking about an algebraic expression, what I'm talking about is the idea that we are putting a puzzle together or a quantity together with a variable. So in other words, what we would be talking about, like for example, I had a certain amount of dogs, okay, and then I added 5 more. And so that would be, this would be the algebraic expression. The algebraic expression has a variable, and it also has a number with an operation between them. Okay, we'll get more into specifics about the different types of algebraic expressions, but first I'm going to talk about the numerical expressions, which numerical expressions are just numbers separated by other numbers with operations. So for example, I have 7 dogs plus 4 dogs from the neighbors. This is what I'm talking about, 7 plus 4. Now normally we would say, oh, you have 11 dogs total, and that would be simplifying the expression down to a single number. But in this case, what we're doing is we're just representing it as a numerical expression. Here's some great examples here of word phrases that we're going to translate into algebraic expressions, where we have a quantity and we have an unknown or variable, something that could be designated as another place. Once again, most people, when they see variables, they get really scared because they think all of math is just algebra. And algebra is just a subsection of math that much bigger tapestry of mathematics is expressed without using letters. But the ideas behind algebra is that we have expressions that have placeholders for future numbers. So if we want to designate a future number as 5, we could go ahead and replace that p with a 5, and so we could say 4 more than 5, that would be 9. Or we could replace p, or substitute for p, which is a more common phrase that a fellow teacher has taught me very valuably, is replace the p, substitute the p for 5 or 7. And if we go 7, we would be reading it as 4 more than 7, and that would be a numerical expression at that point, which we could simplify, and we'll talk about those a little bit later, to get 11. Okay, so that's the number that we would be representing. So right now what we're going to do is we are just going to find these we're going to redefine these in algebraic expressions. Now, Khwarizmi, when he was simplifying this stuff and solving algebraic expressions in the past and equations, he would do it by word of mouth. So he used nothing but word of phrases. So that was the really cool thing about this dude, is that he would just use word phrases for this. So what we're going to do is we're going to use a more recent thing, which is we're going to use symbol notations to represent this word phrase as a symbol notation, which most people who have taken an algebra course in either high school or secondary school will recognize as the algebraic expressions that we know today. So this would be 4 more than would be P. Okay. Now I just want to get the ideas down of how we translate to algebraic expressions, and then we'll start talking about what they would actually be. So I want you to take some time, and I want you to think about the next one. This one's adding a new word, quotient. What do you think quotient means? Now hopefully you thought of quotient as division, and this one's a little bit interesting because we have the quotient of n and 8. And in this one, the order does matter. So the quotient of n and 8, this one will come first and this one will come second. So there are two ways to write this. We can go n divided by 8, okay, or we can write it as a fraction. It's totally up to you. Now you can use a division symbol in place of that slash. Because I'm typing on a keyboard, I'll be using the slash more commonly, okay? Okay. Now this is the other way to actually write it out, is as a fraction bar, okay? All right, now this next problem is pretty much the same as the second one, except the order of the variable and the quantity that we do know. So the quotient still means division, but now we have the quantity first and then we have the variable second. So let me show the two ways you can rewrite this. So we would have 17 divided by k, or 17 over k. It's up to you how you want to do it. Some people use the colon for ratio. We won't talk about ratios until we get later in the topic of the whole idea on Algebra 1. And dealing with proportions is when we really deal with that. But ratios we're not going to use here because we're going to use division. All right, now the next part's 23 less than x. Okay, so 23 less than x, you're probably sitting there going like, oh, that will be 23 minus x. And if you notice, I went ahead and typed 20, so that's crazy. Okay, so 23 less than x, which that makes sense. You associate, okay, 23 is our known quantity, x is our unknown, and then this less than is usually subtraction. And usually you would be right, except we're talking, if you put in place of a number with the variable, if you actually, now that we know it's a placeholder and we put a number in its place, it will make sense why this is incorrect. So for x, I just replaced it with a 45. So what we're doing is we're reading this as 23 less than 45. Well, that's not 23 minus 45. That means I had 45 to begin with, and then I minus 23. Okay, and that's going to be our amazing 22. Okay, so that's how we get 22 from this expression. So when I actually put a number in its place, it's going to make sense why I want this expression to be explicitly x minus 23. All right, and that being Michael Jordan's number. Okay, so that's kind of cool. All right, so now since we are talking about taking word phrases and putting them into algebraic expressions, we do need to identify when we're going to use one of the 4 main operators. Now there are other operations down the road, and we'll talk about them in the next one for Algebra 1. But for right now, we're just dealing with plus, times, minus, and divide. So if you think you've got some ideas, go ahead and write them down on some paper right now and see if they match what most common expectations are for plus, minus, divide, and times. And if you'd like to leave something in the comments about a different idea, I totally am welcome to that. So take this time to pause the video and go write down what your ideas are. Hopefully you got some of these ideas, and if you got different ideas and you want to totally share them with me, that is totally cool. I will totally accept that. Okay, but with the plus sign and the minus sign, I thought we would start with the simplest. I want you to check off, did you have more than, sum of, plus, add for addition? Also, for the subtraction sign, did you have less than or difference, minus, or subtract? Okay, those are the 4 big ones that really kind of come up and let you know, okay, we're dealing with something that's different from other things and is a specific operation in itself. Okay, now let's check times and divide. Hopefully you came up with these ones right here. For multiplication, we have times, product of, multiply. You could also multiply by fractions. So if you find that you're doing something that's really kind of unique like this, okay, a third of a number n, well, this is basically you're taking a third of a number, so you can multiply, since this is 1/3, you can multiply 1/3 by n, and that would represent multiplication. Now that also leads us to the next part, which is division, which has divide, quotient of, take a fraction of something else as well, because I could rewrite this as a third of a number n. I could rewrite this as n divided by 3, or the other one, which would be the fraction, n over 3. So as you can see, it depends on how you look at it. You could represent a third of a number or a fraction, like you could say 2/3 of a number n, and you could go 2/3 times n, or 2 times n over 3, or 2n over 3. It's totally up to you how you want to do it. They all represent the same ideas, that we're taking a fraction of something else. One is division, one is multiplication, and one is through division. And it really is to each their own type of idea. Okay, some days I prefer this method of 1/3 times a variable, and some other days I prefer to go, oh, I'm just thinking about it as dividing, so let's just do it that way. Okay, now notice how I'm not dividing by 1/3. If I divide by 1/3, we'll talk about that more when we talk about how to evaluate and work with stuff. But when you divide by a fraction, you have to multiply by the reciprocal. Okay, so for example, let me show you. N divided by 1/3 would have to be rewritten as n times 3 over 1. Okay, and that would be just 3 times n in the long run. Okay, so that is something that we do have to take into account, that we're not actually taking a problem and we're dividing it by a fraction. We're going to take a fraction of something else and we're going to re-represent it like this for division and like this for multiplication type problems. Okay, all right, and that's pretty much it for talking about algebraic expressions, number expressions, and also word phrases in algebra, which came from al-Khwarizmi back in the 9th century Baghdad, who is our historical mathematician that we'll be talking about. And he came up with all these cool ideas that we still use today. All right, thank you so much, and have a great day, and I'll see you again in the future.